So as I continue my 386DX build, where I last left off was to the point of really trying to get my memory, the static RAM, up and working. And I had some other cleanup to do prior to get to that, but really that's where I'm picking up here. And so this is a visual of my prototype board that I'm using. And what I'm focusing on is getting these 4 chips working. And I have had a lot of questions on the different timing aspects and just logic coming from Intel's guidance in their hardware reference manual. And so I've been working on that and trying to get some of this timing cleaned up and just filling in logic of maybe what's not explicitly laid out in the manual, but has some pretty good guidance. I just needed to do some experimenting and rereading that content multiple times and trying to get this dialed in a bit. So in that Intel hardware reference manual, there is this figure 8-4 that I'm using consistently. And that's really what I'm basing my design off of. So as I look at my system running and the board that I'm building out, this is what I'm trying to model it around and to see if I can make that work. Other than the fact that I've gone to, instead of a pair of ROMs, I have 4 of them that are sitting right here. And I'm actually, I think as I get closer to a final board, or the next revision of a board, I should say, I probably am going to go with 4 ROMs instead of 2. So previously I've talked about that. There are benefits to both 4 ROMs and 2 ROMs, but I'm going to go with 4, I think, as I go forward. So that's a deviation I made to this visual here. And then they have, 4 static RAMs, and that's my 4 static RAMs sitting down here. And then there's all of this other logic either in these 2 PALs. And so those PAL chips I have implemented pretty much as is from the hardware reference manual. So I have implemented those. And what I had not implemented previous to this video were these 3 things up here. So what I've done is I've looked at that and said, okay, if I want to get address pipelining, where the processor can read the next address and make it available a little bit early to kind of speed things up and minimize wait states, I needed to figure out this logic. So I did come in here and I added, you can see here they've got a flip-flop, a 7474 flip-flop, and then these NOR gates. And so what I did when I laid this board out is I left some spots, just empty IC spots. There's a bunch of them scattered throughout that are just there. There's nothing wired to them except for power and ground and a capacitor beside them. But I took advantage of a pair of those. So I came over here and I put in a 7474, and then I came down here and put in, I actually went with a 7402 instead of a 27. So mine are 2 input NORs instead of 3 input NORs. And basically I'm using this one here. I only need 2 in the first place, but the way they've done this, and I don't have other logic coming in here at the moment. So just scratch that. And I have a pair of these NORs, and I have the flip-flop. And of course, underneath this board is where I have all these wires connecting, but basically connecting what you see here to make that circuit. And really what this is doing for me is giving me this NA address. Previously, I had mistakenly thought that this NA out of this PAL is what went directly into this NA up here. Well, one little subtlety that I didn't pay attention to or didn't notice is this is an NA bar. So it's an active low that's up here. And this one down here is an active high NA, where this is this next address signal. And then, of course, going through this logic got it to the active low. So I fixed that, and so I've updated my schematic accordingly. I'm running it through this logic here, and now I have an active low NA coming into my 386 processor, and that helps handle this address pipelining. And this is what my actual schematic looks like. I'm using Easy EDA, but in that tool, this is how I've drawn that out. Something else, there's also a RDY, active low RDY coming out of pin 12 of the second PAL, and I've just connected that into the ready active low for the rest of the system. So I noted that, and then I also noted that I changed this NA active low to an NA active high, and then here's this other logic through those 2 chips. This is probably more sensible to look at in this form of gates, but down here are the actual IC, how I have that implemented up at the moment. So I did that, and then I got in and I have my little debugger that I've been using. So again, I've got this debug board with this Nucleo 144. It's an STM32 based board, and that's helping me do this debugging. And I showed this screenshot in a previous video. I did enhance that quite a bit, and I've now had the additional columns you can see down here. I'm capturing a lot of data through this. And that is, I found that to be extremely helpful. I don't think I would get to the point where I'm at now without having had this. Now, what I'm doing, I'm also up here plotting the actual kind of a histogram line chart as I go left to right here. And so down below, what I'm doing is I'm fetching and showing data only when it is my clock 2 is high and my clock is high. So when that clock signal goes from low to high, I fetch the values at that point and I record it down here. And you can see I'm recording quite a few things. So I've got my clock 2, my clock reset, which of these time phases I'm in, 1 or 2, am I doing memory or IO, this MIO DCWR, that tells me this information of what bus operation is it, and all these other signals that I need to be using as I build out this system. But then this plotted information up above, the way that I'm doing that is currently I'm just having it cycle 100 times per second and fetch that data and plot it. And this little number down here, if you see me running this application, is just showing the rate at which it's actually doing that per second. So when I captured this, it was processing at 99. The most recent second was it captured 99 pieces of data and plotted all of it. So I've got all these important signals up here, all of the address signals, and if I keep scrolling down, all of the data signals. And it seems like a lot, but when I've gotten in here and started debugging, really what I'm looking at is at what point for example, does my ROM read go active, or my RAM read, or my RAM write? When are those going active in comparison to the data enable that I'm going to be using on my transceivers, or the address latching, or am I doing a transmit or a receive? When is the ready signal? I also had to clean up a little bit with my ready signal. All of this is really helpful because then I can tell is something happening at the wrong time. And as I was using this, I found a visual output that looked like this at one point. And this caught my eye, and I'm like, that doesn't look good. So as I looked at data 7, all of this bouncing, something seemed wrong. It seemed like, floating input, right? So maybe it's just floating, and that's fine. But then as I came up here, I'm looking at, well, wait a second, I should be doing a memory read, and it is RAM. RAM is active low, and I could see that I should have been doing a RAM read at that point. So there should not have been any floating, and this bouncing, something was wrong with that. So I had to track down what was going on there. I did hook up my actual oscilloscope to the RAM chips. And so I came down to the RAM chips, and I have different signals there. I have the actual output enable. There's a chip select. So chip select, I just always keep low. It's basically always selected in my design. Then the output enable, and then also the write. So here I have an output enable, and I believe this was the write line above it. But then this was the data line for just data 0. So just the very first data bit. And you can see that is a mess. So something was happening going from low to high. I had some middle steps. There's something causing, first thought is contention. But what in the world would be causing contention? Well, it ends up the actual debugger was causing the issue. And so I went over to this debugger, and I did two things. I did add pull downs on the data lines, not on the address lines or control lines, but on the data lines. And even more importantly, the level shifters that I'm pulling between the voltage on my 386 board into the 3 volt here. I have level shifters underneath this, and they are these little chips. Those I had always active, and what I was finding that is when I would go to actually need to pull in data into the RAM, these level shifters, there was something coming back that was causing this contention that you're seeing up here. So I had built this PCB with a jumper where I could control the output enable, and right here, this is showing it was just hard. It was tied to 3.3 volts, so basically it was always outputting. Well, I changed that, and instead of that just being set to 3.3 volt, I'm actually pulling a pin from the STM32 board and programmatically turning on and turning off these level shifters. And basically, I only enable output when I'm actually wanting to read the value from the STM32. And in all other cases, I disable or turn off the output of these level shifters. And that helped tremendously. And basically, here's the code that I have on this STM32. So every time I want to read the values, I go through some code, and you can see this code here. But in that, I basically am using, let's see, where is it at? PG1. So there's a port G, pin 1, and that ends up on this board being this pin right here. So I've connected that pin down to this down here, and I just simply pull it high right before I'm going to read values from all the ports, and then I take it back low. So I'm only enabling these during this short amount of time where I quickly read the ports and get out as quickly as I can. And that's been good. So since I've done that, now the output looks much cleaner. And over here, everything looks much cleaner too. So address data, everything just is looking pretty good. Still not done though. As I was going in and looking at this, for some reason, I was not getting RAM reads working. It seemed like the writes, as far as I could tell, all the signals and timing looked good, but the reads were not coming back with the right information. So I worked through some timing updates in my logic, but as I was doing some debugging, this tool came in handy again where I could see, like right here, I'm trying to do a memory write, and specifically a RAM write, and I'm logging over here which of the RAM chips are enabled to write. And it should be a 0 if I'm going to write to one of them, and these are all 1s. So that told me that my system's trying to write to RAM, but none of the individual write enables are turned on. Now in some cases, maybe just the low 2 are turned on, or maybe in some cases it's all 4. There's different combinations, but in this case, this is showing me none of them were getting turned on. So that just got me back into going through all of this code. So I have these PSOCs. I have a PSOC here and a PSOC here. And I'm really glad these were PSOCs and not discrete logic, because I've been changing that around a great deal as I've been just going through and troubleshooting and trying to get all of this to work. But I made updates to those. So here's the first one. This happens to be generating this S0B and S1B signal. I'm also generating this ADSO, B for an active lower bar. So I bring in an ADS, and I wasn't sure exactly what needed to be done to get an ADSO, but through the reading and research I've done, it seems like I just simply have to gate it on the clock signal. So I got that done. So this brings in and generates my clock 2, it generates my clock, it generates my P clock. So those are 3 different clock signals that at different speeds that I'm using. I also have my reset now synchronized to clock. I think that all is correct. So this logic, I think, is on the right track at least. It seems to be pretty close. And then I had this diagram from the hardware design guide, and it was showing, generating these wait state 1, wait state 2, and that had to go over to this S0, S1 generator. So those get used back on this other thing down here. And this is what I had built out for that, or this is what it currently is. And that seems to be what it needs to be. So, so far, I think so good on that. I probably still have some work to do all the resets when I reset the system across all of it to reset things, but that's work to come later. And then I had to go in and update. There's a LUT that I'm using to help generate this CS1 wait state active low and a CS0 wait state active low. And there's also an IO active low. So I've got some logic there. And I have populated this table, basically this lookup table, It's basically looking, is it a ROM read or is it a RAM read or write, or is it I/O? And then it sets the wait states accordingly. And this is how I'm doing that right now. So I'm doing one wait state for RAM. I'm doing no wait states for ROM. And I have experimented with that, and what I am finding is that the RAM, at least in this setup, I do need this CS1 instead of CS0. So that all came from just looking at the schematic, how they've got that, and basically I tried to mimic that. And then I also had to put in logic for when does the ROM enable for output to turn on, when does the RAM enable for either reading or writing, when are those active, when are they low, in other words. And so I've worked through this logic. I have tied the logic into those wait states accordingly. I'm doing my latching, and then I'm also looking at am I supposed to be doing a read or a write at the time. And so all that logic really just gives me these three signals, whether I'm going to read my ROM, read my RAM, or write my RAM. And then I also have to deal with these 4 specific write enables on these 4 RAM chips, and so I put in some logic to handle that. And that's pretty basic logic. Basically, it looks at these BE 0, 1, 2, and 3 signals, which are active low, and that along with am I in the middle of a RAM write? If so, then flag that signal accordingly, or set that signal accordingly. Now, as I'm doing all of this, I'm really going back to this figure from that hardware design manual the most often. So this is just helping me understand, where does my address latching need to happen? Where do I have to enable my transceivers? So when am I going to latch my address? When am I going to enable transceivers for data? Am I doing a read? Am I doing a write? When should I be marking that I want to grab the next address for pipelining? Where does my ready signal need to happen? Where does clock and this ADS fit in? I got address data, line data, etc. So there's all those different signals that I've been working with. And to test all of this, I'm using this assembly code, very basic assembly code, but this helps me test my RAM. And here's what I'm doing in this. So when I turn on my system, it starts down here at the bottom, and I jump up to the start of my usable ROM, which will be right up here. And for now, I'm not setting up any of the registers, so just ignore that. It's fine for the testing I'm doing. I turn off interrupts, and then it falls into this basic test loop. And so I move a 0 into this memory variable, this location, and then I have a loop. And I'm going to take that variable, move it into my EAX, and then I'm going to call a procedure, this inc test mem. I'm going to increment whatever's in that location, and then I'm going to return, and then I'm going to jump through the loop again, move it from RAM into EAX. I'm going to call this increment, which is going to do the increment. Now, the only reason I'm really doing this move into EAX is just so I can see some of the stuff move in my logging. This really is serving no purpose. You don't see anywhere else that I use EAX, but that's fine. So basically grab this, pull it in so I can tell that I read it. I call this other procedure. When I call that other procedure, it should write to memory, to my stack, so that I know at the end of this how to return. And so those are things I'm looking for when it comes to the RAM. Am I, first of all, writing a 0 to that location? Am I reading from that location? Am I keeping track of my stack so I can know where to return from when I do my jump, and then return back, and then work through all of that? And so with that, maybe what I'll do is I have this actually running. You can see my system here is running. I'm running a moderately slow clock, but that's just so I can do some of this debugging. And so here, first of all, is the current debug viewer, and I have it connected right now because it tells me disconnect, and down here it says connected, not displaying. So I am connected from the PC to this debugger through this USB port. And you can see the signals up here, clock 2, clock, reset, MIO, DC, all the way down to here, address 31. I scroll down through my address all the way to 0, and then data 31 all the way down to data 0. And so if I just hit start, this is just showing what is it capturing off of this currently running program. And I'm just going to let this run for a second and then I'll pause it. But I can kind of look at this and I can see it's in the C thousands, the low C's that it's reading. I just saw that 05AC. That's where that memory location is, that it's updating as it goes. FFFE, that would be my stack. So I can kind of just catch what's going on as I go through this. And of course, up above, I can look at my clock and I can look at all these signals and try to figure out what's going on. And this representation up here is pretty close, so the timing is pretty close to what's actually happening. Again, I'm sampling 100 times per second. And for some reason right now it's saying 463 is how many it's processing. So maybe I've changed something that's running a bit faster. It shouldn't be running that fast, but we'll see if that updates later. But I'm logging all of this. And in this, I'm trying to catch a few things. And I've stared at this long enough now that I can look at it and I kind of know what I'm looking for pretty quickly as it's scrolling by. But I'm going to stop this. I'll wait till it gets to the end of drawing to the right and then just talk through this a little bit so you can kind of see, what have I been going through to try to figure this all out. So I'll just do a stop there. And, again, I can scroll through all of this and see and look at timing of all of this. I can look at my information down here. But if I scroll to the bottom of this bottom pane here and just look backwards a little bit, so 05AC, I know that happens to be that location of that memory address that I'm reading and trying to increment. Over to the right, I have columns that I'm paying attention to. Am I doing a ROM read, RAM read? Which of the specific wait states am I using as I'm doing that, a 0 wait state or a 1 wait state? Do I have my data latches enabled? That's this DEN. Am I reading or writing? Am I asking for the next address for pipelining? Am I latching my address? Am I doing a read or a write? That's the MRTC or MWTC. And then these last bits are showing me which specific RAM chip is actually open for writing right now. This address 3 and 2, this is pre-latch, just so if I have any timing concerns, I can kind of compare it to the addressing I see over here. But I might go up a bit, and if I look at this, let's just pick, for example, so this would be my C0010. That's the address that this is doing something. And if I look at it, I can see that it latched an address here. So that's the address it's working with. And then I can look for these ROM read lines. And there's 2 lines that I could look at and says, okay, I'm going to read. And it reads here, basically, I think I'm looking for this clock to be high. So this is the line where it's actually going to this address. I know it's doing a 0 wait state ROM read, and my data transceiver is enabled, and I am doing a read. And MRDC also tells me I'm doing a read. So I'm doing a memory code read from a certain address, and this is what I pulled out of this is part of my program, basically. It's loading up some of that code to pull that and run that. And then I can see it stepped forward 4 bytes and does another ROM read, and I can look at that and see that it pulled out this part of my code, and then it does another ROM read at the 18 address. And basically I can just work my way down. And what I'm really looking for is, where my address transceiver is enabled, am I doing a ROM read, and what was it that I was using for an address and data. And as I go through this, you can see it's working through the program, and then eventually it gets the looping and it's going to jump back to a lower C something. Like back here, it kind of jumped back and started that loop again. So between here though, where it gets to this 5AC, I can see that it here did RAM read, and I can look at the RAM read and figure out what did it pull out. It pulled out a 38B, and then eventually it's going to do a RAM write. So here it wrote out a 38C. So it read a 38B, it did the increment, and now it's writing out the 38C. And then it goes out here and does a RAM read. This is pulling from should be the stack. So this is where it's going to return to as far as addressing is concerned. And then, of course, I get back and I actually do that return. But that's the type of thing. I'm just having to go through this. I'm looking at what do I have up here? Is there anything that just doesn't look right? looking at the timing diagrams from what Intel has provided. Now, this is working, so I know I'm using the stack properly, which requires RAM writes and reads. I can see that it's incrementing the value as it goes in memory. Again, that requires RAM reads and writes. And I can look through all of this, and I'm not seeing any goofy, just, loading type of activity. So this all feels pretty decent. And I can really just analyze this then and see, is there something else I'm missing or anything that looks weird? But I think at this point, this is working, RAMs and reads, at least a slow clock. I have not done any testing to see if I can run an actual faster clock, megahertz or faster. So that'll come later. And I think I now also want to get in something I can actually do something more productive. And maybe what I'll try getting in, I have a little Arduino Nano that's going to sit right here that will let me do SPI and connect to it through SPI and then send serial data to my PC. So at that point, I should be able to start actually writing something useful to the PC for logging data more than just trying to read each of these bits. I can write out strings and what's going on and do calculations, whatever it might be. So that's probably coming up next then, is can I write code to actually do some SPI manipulation of that Arduino Nano and write to the PC with that. And if that works, that's all a great sign, especially if I can run that at a megahertz or faster. And then post that, then I can start getting in other things like coming over here and getting my keyboard input and mouse input working. All I care about is keyboard right now, but get my keyboard input working. And then I think after that, then I can come back and put in a video card. I have a video card that I've been using in my 286 build that should work fine in here. And then I can try to get that working. And so those would be major milestones coming up. But this was a major milestone, getting my RAM writes and reads and just all of this miscellaneous timing and glue logic to the point at least where it's working. Now, how well it's going to work at high speed is to be determined, but this was a big step for me, so I'm quite happy with this. So that's where I'm at. Thanks for taking this half hour just to kind of listen to the updates here. And as always, if you've got thoughts on what I'm doing here, feel free to drop a note below. I'm kind of learning my way through this, and it feels good to get some progress here, because this was a lot of unknowns for me that I had to figure out, and I think I've figured out quite a bit since the last major update on this specific build. And I'll go back and just say it again, this debugger and this software on the screen has really helped me figure out what I've had to work through to get things cleaned up. So extremely helpful. But having the DXL processor along with this debugger has been awesome. So good enough for now. Thanks for watching, and more to come.